Hi everyone. Okay, so today we we'll do formula sheet. Hold on, where's the chat? Okay, well you can search up the formula sheet right now. I have it out here, will be hard for you to read. So first on the formula sheet is how to find the average. You probably don't need it because you already know how to find the average. Just the sum of the x divided by n. And then this equation tells you how to find standard deviation, sample standard deviation, because it's n minus 1. The next is the regression equation, y hat equals a plus bx. Remember, a is the intercept, b is the slope. And this is just saying y bar equals a plus b times x bar. That's just saying that x bar, y bar lies on this equation. And then over here, this is just how to calculate the correlation coefficient, R, but you really don't need to know how to do that because you'll most likely just be given that. To find the slope, you do B equals correlation coefficient times SY over SX. Now onto probability. So again, you should pull this up online. You can just search up AP Stats formula sheet. Anyway, so probability A or B. This is the general, so it doesn't need to be disjoint. This is general, this is the conditional probability. So probability A given B is probability A and B over probability of B. Now this is probability distribution. So binomial and geometric. So remember, geometric is how many until your first success, while binomial is how many successes in a given number of trials. So, and remember, discrete variables when you can count it, while continuous is like a norm model. It can be in between. You can't count it. So binomial, the mean is also expected, and that is n times p. And then the standard deviation is square root np times 1 minus p, and we often write q equals 1 minus p, so standard deviation is square root npq. And then geometric, to find the expected or the mean, you do 1 over p, and p is probability of success. And then standard deviation, you do square root 1 minus p over p, which is q over p. And this over here, this top row is in the table. You have three tables like outcome, x value, and probability. So it's how you'd find expected. So you do sum of x times probability. For expected and standard deviation, you do the mean. You first calculate expected, the mean, and then you do the x minus mean squared times the probability. So it's one of these outcome. This is chapter 16, x value and probability. So it could be like small, large. I think is this example. $25, $100, 0.75 probability, 0.25. Remember, the probability should add up to 1. So expected, it's telling you how to do that. Expected 0.75 times 25 plus 100 times 0.25. How to find standard deviation, etc. All right, now sampling distribution and inferential statistics over here. So this is talking about in general. So to find the standardized test statistic, which is, for example, t or z, you do z or t equals the statistic minus parameter over the standard error of the statistic. So that would just be, if you have a normal, so this is for z, you have a normal model, that you have the mean, and for example here, so So it would be like z equals the statistic minus the parameter over the standard error. Confidence interval statistic. So I'm giving you an example right now. Let's talk about proportions. So it'd be p hat plus or minus statistics times critical value. Again, we're doing proportions, so I'm using z star. So critical value times standard error. Standard error p hat. Remember, z star times standard error is also the margin of error. So then chi-squared statistic is sum of observed minus expected squared over expected. So that's telling you, again, chi-squared is sum of observed minus expected squared over expected. So now let's go to the next page. If you're looking at online, you can just scroll down. Again, you'll have this with you for the whole exam, so it'd be wise to use it. Now parameters of sampling distribution. So the mean is going to be p, so that's basically saying like the center is p of the normal model. That's the standard deviation of p hat is square root of pq over n. And then if you're doing standard error, then you're doing of a sample, then you're doing square root p hat times q hat over n. And then for so this is one sample. This first row is one sample. Now this is two proportions, p hat 1 minus p hat 2. And if you're doing parameters, p over q over n, p times q over n plus p times q over n. And then if you're doing standard error of a sample, you do p hat, q hat over n, etc. Now moving on to random variables over here now. So this is standard rules. Oh yeah, so like when you're this is just saying the mean, so like the center is the mean. Standard deviation is, so this is again for means, okay? So standard deviation over square root n to find, so this would be the sample standard deviation. And then this last one, the only kind of important one you really care about over here is this one. So for sampling distributions for simple linear regression, so to find the slope, you want to do the mean equals beta. So yeah, that is a quick video on the formula sheet. Thanks for watching.